We're asked, what are the domain and range of the sine function? So to think about that, let's actually draw the sine function out. And what I have here, on the left-hand side right over here, I've got a unit circle. And let me truncate this a little bit. I don't need that space right there, so let me clear that out. So I have a unit circle on the left-hand side right over here, and I'm going to use that to figure out the values of sine of theta for a given theta. So in the unit circle, this is x, and this is y. Or you could even view this as we could just use it as x or y. And so for a given theta, we can see where that angle the terminal side of the angle intersects the unit circle, and then the y coordinate of that point is going to be sine of theta. And over here, I'm going to graph still y in the vertical axis, but I'm going to graph the graph of y is equal to sine of theta. Y is equal to sine of theta. And on the horizontal axis, I'm not going to graph x, but I'm going to graph theta. You can view theta as the independent variable here. And it's going to be theta is going to be in radians. So we're essentially going to pick a bunch of thetas and then come up with what sine of theta is and then graph it. So let's set up a little bit of a table here. And so over here I have theta, and over here we're going to figure out what sine of theta is. And we could do a bunch of theta values. Let's say we start at 0. Let's say we start at theta is equal to 0. What is sine of theta going to be? Well, when the angle is 0, we intersect the unit circle right over there. The y coordinate of this is still 0. This is the point 1, 0. The y coordinate is 0, so sine of theta is 0. Or you could say sine of 0 is equal to 0. Sine of 0 is equal to 0. Now let's try theta is equal to pi over 2. Theta is equal to pi over 2. I'm just doing the ones that are really easy to figure out. So if theta is equal to pi over 2, that's the same thing as a 90-degree angle. So the terminal side is going to be right along the y-axis, just like that. And where it intersects the unit circle is right over here. And what point is that? Well, that's the point 0, 1. So what is sine of pi over 2? Well, sine of pi over 2 is just the y coordinate right over here. It is 1. Sine of pi over 2 is 1. Let's keep going, and you might see a little pattern here. We're just going more and more around the circle. So let's think about what happens when theta is equal to pi. When theta is equal to pi, what is sine of pi? Well, we intersect the unit circle right over there. That coordinate is -1, 0. Sine is the y coordinate. So this right over here is sine of pi. Sine of pi is 0. Let's go to 3 pi over 2. 3 pi over 2. Well, now we've gone 3/4 of the way around the circle. We intersect the terminal side of the angle, intersects the unit circle right over here. And so based on that, what is sine of 3 pi over 2? Well, this point right over here is the point negative, let me be careful, is 0, -1. The sine of theta is the same thing as the y coordinate, or the y coordinate is sine of theta. So when theta is pi over 2, sine of theta, or when theta is 3 pi over 2, sine of theta is equal to -1. And let's come full circle. Let's come full circle here. So let's go all the way to theta equaling 2 pi. Let me do a color. Yeah, I'll just use the yellow here. What happens when theta is equal to 2 pi? Well, then we've gone all the way around the circle, and we are back to where we started. And the y coordinate is 0, so sine of 2 pi is once again 0. And if we were to keep going around, we're going to start seeing, as we keep incrementing the angle, we're going to start seeing the same pattern emerge again. Well, let's try to graph this. So when theta is equal to 0, sine of theta is 0. When theta is equal to pi over 2, sine of theta is 1. So we'll use the same scale. So sine of theta is equal to 1. I'll make this is 1 on this axis and on that axis, so we can maybe see a little bit of a parallel here. When theta is equal to pi, sine of theta is 0. So when theta is equal to pi, sine of theta is 0. So we go back right over there. When theta is equal to 3 pi over 2, so that would be right over here, 3 pi over 2, sine of theta is negative 1. So this is negative 1 over here. I'll do the same scale over here. I'll make this negative. Let me draw a little bit. I'll make this negative 1. And so sine of theta is negative 1. And then when theta is 2 pi, sine of theta is 0. So when theta is 2 pi, sine of theta is 0. And so we can connect the dots. You can try other points in between, and you get something. You get a graph that looks something like this. It looks something like this. My best attempt at drawing it freehand. It looks something like this. There's a reason why curves that look like this are called sinusoids, because they're the graph of a sine function. So just like this. But that's not the entire graph. We could keep going. We could add another pi over 2. If you added another pi over 2, so if you go to 2 pi and then you add another pi over 2, so you could view this as 2.5 pi or however you want to think about it, then you're going to go back over here. So then you're going to get back to sine of theta being equal to 1. So you're going to go back to this point right over here. And you could keep going. You go another pi over 2, you're going to go back to this point, and you're going to be over here. And so the curve, or the function sine of theta is really defined for any theta value, any real theta value that you choose. So any theta value. You say, well, what about negatives? I mean, obviously I agree. As you keep increasing theta like this, we just keep going around and around the circle, and this pattern kind of emerges. But what happens when we go in the negative direction? Well, let's try it out. What happens if we were to take negative pi over 2? So let me do that. So negative pi over 2, well, that's going right over here. And so we intersect the unit circle right over there. The y-coordinate is negative 1. So sine of negative pi over 2 is negative 1. And we see that it just continues. It just continues. So sine of theta is defined for any positive, negative, or any theta. Positive or negative, non-negative, 0, anything. So it's defined for anything. So let's go back to the question. So I could just keep drawing this function on and on and on. So let's go back to the question. What is the domain? What is the domain? What is the domain of the sine function? And just as a reminder, the domain are all of the inputs over which the function is defined, or all of the valid inputs into the function that the function will actually spit out a valid answer. So what is the domain of the sine function? Well, we already saw we can put in any theta here. So you could say the domain is all real numbers. All real numbers. Now, what about the range? What about the range? Well, just as a review, the range is sometimes in more technical math classes called the image. It's the set of all the values that the function can actually take on. Well, what is that set? What is the range here? What is all the values that y equals sine of theta could actually take on? Well, we see that it keeps going between positive 1. It keeps going between positive 1 and then to negative 1. And then back to positive 1 and then negative 1. It takes on all the values in between. So you see that sine of theta is always going to be less than or equal to 1. And it's always going to be greater than or equal to negative 1. So you could say that the range of sine of theta is the set of all numbers between negative 1 and positive 1, and it includes negative 1 and 1. And that's why we put brackets here instead of parentheses.